By default, the permission is star, because what the developer has to do is they have to actually manually check the origin that's attached to the event. So you get this event object passed in, there's a value called origin, which says where the message came from, and then it's up to the developer to actually physically check to see if it came from a domain that they trust. If that check's not there, what ends up happening is it ends up being a star, sort of an allow domain star. So if it doesn't come in from a domain that you trust, you can just go ahead and return and ignore the message. Otherwise, you can go ahead and get the message which was passed across between the two frames. So those are the two newer cross-domain models that have been introduced in HTML5. Plugins have also been making advancements within their cross-domain models. I talked yesterday about Adobe's cross-domain model. It's been around since 2005. We tweaked it around 2008, 2009 to add a few more controls to it. But basically, it's a cross-domain.xml file that's hosted in the root directory of the server. One of the nicer things about the Flash model is if you want to know whether the site shares information across domain, you can go to a single place in the site, see if that file exists. There's a cross-domain XML file in the root directory. You know that domain shares information across domain. If it's not there, you know that it doesn't. As opposed to some of the ones that use headers where if you're doing a pen test or a black box assessment, you have to actually pay attention to the headers that are going back and forth when you're pen testing the site. The cross-domain XML format has actually started to be adopted by other plugins outside of Flash Player. JavaFX supports it, SilverLight supports it. The support in the other plugins tends to be varying. Right now, I believe in Java, they only support allow domain star. They don't actually allow you to do the per domain comparisons. And similar with SilverLight. They support a subset of the functionality that Adobe currently has defined in our model. So on the one hand, it's nice because if all the plugins tend to use the same model, it makes it easier to audit, to test for, to know what to look for. On the downside right now, it's a little bit awkward because they only support part of the model, and that means they may be, if they use multiple plugins on their site, they may be more inclined to use star now because the other plugins aren't supporting it. Like most of the cross-domain permissions, they allow access to the response body. We don't actually allow access to any of the response headers. You just get to see the body of the location. Authentication is sent with requests in our model, so if there are cookies, it'll be sent along with the request for the cross-domain XML. We do not allow you to share across protocol by default. We do not allow you to share across protocol by default, but the site can choose to override that. We don't encourage them to, but in some dev environments, they set it up that way. You shouldn't see that in a production environment, hopefully. And the refinement is basically per directory. So you can set site-wide policies or you can set per directory policies. It doesn't support per URI policies. And there are three types of controls which are defined in the cross-domain policy file. Obviously, domains with whom you want to share data. Like W3C access control, it says what headers the site's willing to accept from remote domains. And then in the root cross-domain policy file, there's a meta policy which says whether or not other cross-domain policy files are allowed on the server. So by default, Flash will go and check the root cross-domain policy file. If the root cross-domain policy file says, yes, I support cross-domain policy files in subdirectories, then the Flash content can go look for other cross-domain policies within the site. By default, we only check for the cross-domain policy which was within the root directory. So if you want to support multiple cross-domain policy files on your site, you have to manually override that. And this is what it looks like. I think most of you have seen these before. The meta policy is the first line that says master only, which means only the root cross-domain policy file is valid for this environment. Then whether or not you allow content from other domains, and then the bottom section is whether or not you allow headers to come across. So if you allow SOAP action headers, for instance, to be set from the remote domains. So I said with JavaFX, with Java SC 6 Update 10, that's where they first introduced the support for cross-domain technologies. Cookies are sent with their model as well. And if you want more information, you can go find it at that URL. Right now, it's not very, the documentation is a little bit limited as far as what's out there and how Java actually supports it. I'm sure Sun, or now Oracle, is working on that. But that's actually somewhat true for a lot of these models. If you're looking for documentation, the documentation that's out there is going to be somewhat sparse because a lot of these things are new. Yesterday when I was looking at Microsoft's site, I noticed where they had a detail wrong in the sample code that they provided on the MSDN docs. So sometimes you need to play around with the different technologies in order to be able to find out how they work. With SilverLight, SilverLight, as I said, supports Adobe's cross-domain policy file, but they also support their own version of cross-domain policy file, which is known as ClientAccessPolicy.xml. So they support a subset of ours, but they also wanted to have one that was specific for SilverLight and SilverLight's needs, so they created their own. Like ours, the refinement level is either per domain or per directory. They also do not allow you to mix content over HTTP or HTTPS by default. And one thing where it differs from the Flash Player socket policy format is Flash Player has a completely different setup governing whether sockets are allowed, whether Flash content can make a socket connection back to the server. With Flash Player, you have to have port 843 open, and that's where you would host the master policy file for sockets. And Flash Player would go there, check to see if you would check that port first to see if you allow sockets, and then based on the XML configuration file it got back from there, it would decide whether the socket connection request by the content is actually allowed. With SilverLight's client access policy, they just put it within the cross-domain XML, or the client access policy XML file. So you'll see a couple of extra rules there for whether or not you allow socket permissions. So this would be an example of a client access policy file where you can see you have the allow from domains. That's so which domains you allow to make the cross-domain request, and then they have a second XML section for what you're granting to that that particular domain. So here, the resource path I'm making available is / and I do include subpaths within that. So fundamentally, it's very similar, but just the semantics of the XML policy file is slightly different. There are other types of cross-domain communication that you'll see. I don't talk about inter-Swift cross-domain communication, but as far as communication between Swift and the surrounding HTML, that's governed by an allow script access tag. The default value for allow script access is if the Swift and the HTML page were both served from the same domain, they're allowed to talk. If not, allow script access has to be set to always, and that will allow the remote Swift to talk to the surrounding HTML. SilverLight has the same basic philosophy, they just have slightly different tags. Like us, they basically treat the object tag as an iframe tag, so in order for SilverLight zap files and the hosting HTML to talk, they both had to be returned from the same fully qualified domain name. If they're hosted on different domains, then they have a parameter called enable HTML access. And that's just a true false value that says whether or not that SilverLight zap file is allowed to talk out to the surrounding HTML. They also have another parameter for external callers from cross-domain for allowing the HTML to talk into the SilverLight content. So communication can go both ways, both with Flash and SilverLight. With Flash, inside the Swift, you set security.allow domain to allow the HTML to talk into the Swift. But it is a form of cross-domain communication that exists between two pieces of content from two different domains. Same basic philosophy, just different naming styles. So if you put all of these things together, this is sort of a chart that graphs out who allows what. In general, all of these things are trying to do the same thing. They're all trying to allow data from one subdomain to be shared with data from another subdomain. But each group has a slightly different philosophy as far as what type of methods are allowed, whether headers are allowed, whether they support wildcard domains, whether it allows cross-protocol, what the scope is of it. So for instance, with Flash and SilverLight, you can get a refinement down to per directory. With HTML5s, you can actually get refinement down to the file. XDR will not allow cross-protocol at all, just serve as a general philosophy, whereas some of the other ones will allow cross-protocol, just not by default. So what makes it interesting, though, is basically if you're an attacker and you're looking for ways to get into an environment, you're always looking for where subtle differences are in a model, right? These are the types of things you want to keep track of, because if one technology doesn't allow you to do what you want, you may switch over to another technology. And I'll talk to you a little bit about that in a second. So whether now I'm blanking on it. Let me think about it for a minute and see if it comes back to me. It'll come back to me in a minute. I believe what it was is that the cookies would be sent when you load it up as an iframe, but once it's loaded in the browser, cookies aren't shared. So it's sort of a halfway point. So what are the threats? All models try to limit access to HTTP headers. If you're designing a site that's using cross-domain policies, then what you're going to want to do is you want to be careful not to make sure that headers don't get reflected back in the message body, because otherwise that'll work around the issue. So frequently what I look for when I'm modding, for instance, a Flash site that's using cross-domain policies, I look to determine whether they echo JSession IDs back in the URL. A lot of Java servers will pass the JSession ID as part of the URL when you click on a link. Since you're taking the JSession ID out of the cookie and putting it into the page, that means it's going to be available to whoever can actually read the response data back from that. So that's something you need to be aware of. Obviously, if you allow the trace method, hopefully you're not allowing trace, but if you did, that'd be an issue. And obviously, excessive trust can be an issue. Most people know that a wildcard permission can be very risky for a lot of domains, especially if they didn't actually need it. Whenever you're assigning domain permissions, you want to follow the principle of least privilege. And some sites will say, okay, well, I'm not going to assign star because that could be too risky. I don't necessarily trust every domain out there, but I might assign star.example.org. And that can be a risk for two reasons. Yesterday during the Flash talk, I talked about Jeremiah Grossman's YouTube attack, where after Google acquired YouTube, YouTube changed its cross-domain policy file to trust star.google.com. It made sense. They're both owned by the same parent company. But the problem is that whenever you allow star.subdomain, you have to think about how your site's designed and whether you have subdomains that allow end users to upload content. So with Jeremiah Grossman's attack, he couldn't actually get to YouTube directly, but what he could do is he could go to gmail.google.com and send himself a SWIFT as an email attachment. And what that did is put his SWIFT within the security context of gmail.google.com because it was hosted there. And then from there, since gmail.google.com is a part of star.google.com, his malicious SWIFT would be able to make the cross-domain request into YouTube's domain and be able to pull out information. So you have to be very careful whenever you allow star domain because if, for instance, if you have a bug database, if you have forums on your site where you allow end users to upload profile pictures, if you're hosting any of that on subdomains that are part of star.example.org, then that content's going to have cross-domain permissions whenever you set up a